be talking about properties today. So the first thing we got to talk about is what is a property. So let's look up here. Properties are statements that are true for all numbers. So they're kind of like rules for certain numbers about adding and subtracting and certain things that we can and can't do all the time. The next vocabulary word that's important is counterexample. So like an example is a way to prove something is true. A counterexample proves that something is false. So conjecture, remember we talked about that conjectures are guesses. So this is an example that proves that a guess is false. Simplify. Just like it sounds, simplify means that we're going to write our equation in the simplest form possible. Last important word is deductive reasoning. Deductive reasoning is using facts and properties to reach a valid conclusion. So we're not just guessing, we're using some rules and we're coming up with the answer from those. So now that the whole section is about properties, we're going to be talking about specific properties. So let's follow this arrow over here to our properties section. The first property we are going to talk about is a commutative property. The way that it's easy to remember this one is by thinking about community. So let's think about this. The commutative property is the order of numbers doesn't change the answer. So if you're in a community, it doesn't matter who you talk to, it doesn't matter what you do, you're all friends. So let's look at these examples. So the commutative property of addition, we have 2 plus 3 equals 3 plus 2. So it doesn't matter which order the numbers are in, you're going to get the same answer. So 2 plus 3 equals 5, and 3 plus 2 equals 5. It doesn't matter which order you have it in. This also works for multiplication as well. Because for multiplication, if you do 5 times 4, you're going to get 20. And if you do 4 times 5, you're also going to get 20. So they're equal. So it doesn't matter what order you put them in for addition and multiplication, you're going to get the same answer. That is the commutative property. The next one is associative property. So the associative property means that the way the numbers are grouped together doesn't change the answer. So no matter which pair of numbers have the parentheses around them, if you can switch it from different numbers to different numbers, and you'll still have the same answer. So for example, if we were going to do this one, it says 1 plus 3, and it has that in parentheses, plus 4. Let's see if we'll get the same answer as if we do 1 plus, then 3 plus 4. So let's try it real quick. 1 plus 3 gives us 4, right? So 4 plus 4 gives us 8. So our answer is 8. Let's see if the other side does the same. So we have to do what's in parentheses first. So let's do 3 plus 4 gives us 7, and then 7 plus 1 gives us 8. So we see that we get the same answer no matter what. This works for multiplication as well. So even if the 5 and the 2 are grouped together first, it'll be the same as the 2 and the 1 are grouped together. It'll give you the same answer. Alright, the next property we're going to talk about is the additive identity property. That means basically if you put a number plus 0, you're going to get that number again. So for an example, if you do 5 plus 0, you're going to get 5. So if you do 10 plus 0, you're going to get 10. It goes the same for all numbers. Let's look at the multiplicative identity property. This basically means that if you multiply a number times 1, you're going to get that number. So 5 times 1 equals 5, 10 times 1 equals 5, 100 times 1 equals 100, or 10 times 1 equals 10, sorry, and 100 times 1 equals 100. The last property we're going to look at is the multiplicative property of 0. Basically this means if you multiply a number times 0, you're going to get 0. 5 times 0 equals 0, 1,000 times 0 equals 0, and so on and so forth. So we're going to use these properties in a few examples. Alright, make sure you have your notebook out so you make sure you have your notes done, and now we're going to do some practice examples. So here we go. We're going to start figuring out, see if we can figure out which property is used at which problem. So let's look at number 1. We have 5 times 7 times 2, and then 7 times 2 times 5. So I realized by looking at these two problems that we have the same three numbers. We have 5, 7, and 2. But then I realized that on this side, they're in different orders. So I know that this property is the commutative property. Commutative property of multiplication, because we're doing multiplication here. So it doesn't matter what order the number's in. That's how I knew it was commutative. Number 2, I see 14 plus, and I see a group, 9 plus 10 equals a group here, 14 plus 9 plus 10. So, are those the same, That's what they said it is, so let's look at what property we're using. I see here that the grouping symbols, the parentheses, are changed from different groups. So I know that that is the associative property, because associative property means it doesn't matter what groups they're in, you're going to get the same answer. So this is the associative property of addition, because we are adding, not multiplying. Alright, number 3. Let's try to figure out what property this one is. We have 8 times 1 equals 8. Well, I know I'm using multiplication, because I see a multiplication sign right here. But I also know that we are using the multiplicative property of, multiplicative identity property. So how did I know it was a multiplicative identity property? Because that is when any number times 1 equals that same number. Let's look at number 4. We have 0 times 12 equals 0. Well, right away I see those zeros, so I know that that is the multiplicative identity property of 0. Multiplicative property is 0, because we have the 0. Alright, for the next 2 problems, we're going to do something a little bit differently. We are going to look at these 2 problems and try to solve them mentally quicker. So we're going to use these properties to try to make this quicker. Because if we do 40 times 6 times 5, is that easy to do in our heads? Not right away. But let's see if we can try to make it easier for ourselves. Let's look at this. I know, by looking at this problem, that 6 times 5 gives me 30. So, I have 30 here times 40 here. If you're multiplying 2 numbers that have zeros at the end, the one way to solve it quicker is to pretend the zeros are gone for a second. We can do 4 times 3 gives us 12, and then we can go ahead and add that 0 on the end. So 120 is our answer. So that makes it a little quicker for us. Let's look at number 6 and see if we can make that a little quicker for us. We have 97 plus 25 plus 3. Okay, we have some big numbers here. Are we able to solve that in our head quickly? Yes. If we use the associative property, we can choose to group numbers 97 plus 3 plus 25. Now, why did I group 97 plus 3? Because I know in my head that if I add 3 to 97, I get 100. And now it's a lot easier to add. So if I get 100 with these 2 numbers, and then I add 25, my answer is 125. So I didn't even have to use a calculator, so that's awesome. Let's go ahead and look at the next example. Now, if you remember, with our notes, we said that a counterexample is basically an example proving that a guess is wrong. So we're going to come up with our own counterexample. Let's look at the problem. It says, is subtraction of decimals associative? If not, give a counterexample. So first we got to see, is that right? Let's try an example. Let's try 1.5, so that's a decimal. We'll do minus 0.2 minus 0.1. Let's see if that is the same if we change the parentheses. So if we have 1.5 minus 0.2 minus 0.1. Let's see if we get the same answer for both of those problems. Let's see, 1.5 minus 0.2 gives us 1.3. And if we subtract 1.3 with 0.1, we'll get 1.2. Let's see if we get 1.2 over here. Alright, so remember, with our order of operations, we do parentheses first. So let's do what's in here first. So we have 0.2 minus 0.1 gives us 0.1. So now if we take 0.1 away from 1.5, we have 1.4. So are those 2 equal? No. So these are not equal. And this would be our counterexample because it does not equal 1.2 over here. Alright, we're changing our routine a little bit again. So here we go. We are going to try to simplify these two problems. Now, in our vocabulary, we talked that simplifying is basically just making this equation the simplest form possible. And that's usually because you can't find the answer because there's an unknown variable. So in this problem, we have 12 times 10 times z. Now, do we know what z is? No. So we will not be able to solve. So we are going to have to simplify. So I'm going to use what I know about multiplication, and I know multiplication is associative. So I'm going to change where the parentheses are. I'm going to group 12 times 10 together and then multiply by z. So I know I can multiply these two, so I'm going to do what I can do. So 12 times 10 gives us 120. Can we do anything with this z? No. So we're just going to have to plug it on the end. Our answer is 120z. That means when you don't have any symbol between a variable and a number, that automatically means multiply. So 120 times z. Alright, let's look at number 9. Now we have 10 plus p plus 18. Now, what can I do with this one? Well, I know it's adding, so this one's also associative, so I'm going to change the grouping. So I'm going to go ahead and group 10 plus 18 and then plus p. So I know I can add these two because they're numbers, so I'm going to go ahead and do that. I'm going to have 28. Now, can I do anything with this p? No, because we don't know what p is. So our answer is 28 plus p. We can't do any more than that. Alright, if you need to, you can go back, rewind, watch the video again, make sure you have all your notes, that you've done the practice problems, and if you are still a little confused, you can go and look in your book, and on page 44 and 45, examples 1 through 4, and those will kind of walk you through the steps again. And obviously, you can always ask me questions in class. Now, I want you to do a few problems for me to see if you can get them right for next class period, alright? Let's go ahead and look at those. Alright. I want you to try to go and turn to page 46 and do numbers 6, 10, 14, and 15. Those are several different kinds of problems, and make sure that you at least understand how to do those, and if you don't, come with your questions tomorrow. Good luck!